this computer. Okay. Is there anybody in this class in section 1 who has problems reading graphs? I say this because the graphs of mathematics and the graphs of economics have one basic difference. Before we get to that, is there anybody in this class who has totally forgot how to read a graph? Totally forgot. There's nobody. So it was the similar system with the previous the other section. So all of us here are more or less familiar with graphs, right?
Yes, sir.
Okay, lovely. So what we do, let me whiteboard. Okay. So this is the x-axis. Oh, sorry, this. Oh. Okay, so we all know one thing. This is termed as the x-axis, which is horizontal, right?
Yes, sir.
Achha, do you see a word in the word horizontal? This is how my teachers in UK taught me. Do you see a word in the word horizontal? Don't you
Yes,
see
sir.
horizon?
Horizon.
Do you see horizon, and from the horizon, the word horizontal comes, right? How do we look at the horizon?
Yes, sir.
Don't we always look like this?
Yes, sir.
So any rightward movement horizontally is positive. Any leftward movement horizontally is defined as, oh sorry. This is defined as negative, right? Okay. This is the y-axis. We term this as the vertical axis. The vertical axis comes from the word vertex. You know what vertex means?
Yes, sir.
Top point. So the vertical axis is like this, right? Any upward movement is positive. Any downward movement is negative. We all know this. Now, those of us who have done mathematics in high school, we know that this is always the independent axis, right? Do you remember?
Yes, sir.
By definition in mathematics, a horizontal axis is the independent axis. By definition in mathematics, the vertical axis is the dependent variable. Okay? There's no problem with this, right? Is there any problem with this? By definition,
No, sir.
x-axis is independent, y-axis is dependent. We'll change this later on. But before that, what do we mean by independent and dependent?
Y will be depending on X in terms of value.
Now I'm going to do it verbally.
On the
Okay. Independent variable by definition is always the variable that changes first. Do we agree?
Yes, sir.
Yes, sir.
Okay. What is the dependent variable? Dependent variable has two characteristics and both have to hold at the same time. One changes after independent. Two changes because of independent. This is how we develop the relationship. Does anybody disagree with what I've written regarding the dependent variable? The independent variable by definition is always the variable that changes first, And by definition, we always put it on the right side of the equation. The dependent variable has two characteristics. Number one, it changes after the independent variable. It changes because of the independent variable. Now, let me give you an example. Who is Bangladesh's best test batsman?
Tamim Iqbal, I think. Best test.
It's Mushfiqur Rahim, because he's the only
Mushfiqur
person
Rahim.
who has 3 double centuries. It's not a joke. Okay, nobody has 3 more than 1 apart from Mushfiq. So that's why I'm saying that he's the best. People will have different personal opinions. Now let's assume that Mushfiq is playing, and the first 2 balls of the over, he scores a boundary. So everybody's happy. You and your friends are watching. Now, just before the 3rd ball, one of your friends enters the room. That's the first event. The moment he or she enters the room, in the 3rd ball, Mushfiq gets out. That's the second event. Can we say that the 2 events are related to each other? Your friend enters, first event. Dependent variable always is the one after the first independent variable. So Mushfiq loses his wicket just after your friend enters. Can we say that the 2 events are related to each other?
Not related.
No, sir.
Not related, but they happen one after another, right? Did they
Yes,
happen
sir.
one after another?
Yes, sir. But here, who is the independent and who is the dependent?
That's why the second condition has to hold. Where is it? Oh, here it is. This one. Because of independent variable. Yes, Mushfiq got out after the friend entered the room, but Mushfiq did not get out because the friend entered the room. Now do you get the logic?
Yes, sir.
Yes, sir.
No,
Now,
sir, in this case, sir, my friend is the independent variable.
no.
So,
The 2 events are not related to each other.
oh, I know that.
The reason why I'm saying is that we sometimes can make a mistake, and lots of people do make a mistake, that just independent variable will always be the variable that changes first. Dependent will be the variable that changes after the independent variable. But if this condition does not hold, the second one, then just because 2 events happen one after another does not mean there is a functional relationship between them. Okay, let me give you another example. We do. Is this a independent dependent variable?
Yes, sir.
So you see, the price changes first. Oh, sorry. Price changes, whether it goes up and down doesn't matter. Changes. Quantity demanded changes after, plus due to change in price. Do we agree?
Yes, sir.
So in this case, we have a functional relationship where we can say that the event that happened first, that the price change, influences the event that happened second, the quantity demanded. Or if we want to look at it in a different way, that the change in the quantity demanded is after the price change and because of the price change. All right?
Yes,
Okay.
sir.
Yes, sir.
Okay, now let me, I'll come to that later. So have we agreed that the x-axis is the independent variable according to mathematics convention,
Yes, sir.
Yes, sir.
and the vertical axis is always the y-axis, right?
Yes, sir.
Yes, sir.
Now, if we say like this, then we go back again, because we are now going to change the convention to economics convention. Colorটা কই? The color. Ah. So this is X, this is Y. Oh, with the eraser. What is the inclination of this line?
Is this a price ceiling?
Mm-hmm. Forget whether it's demand or supply. What is the inclination?
Sir, X is constant.
Wait, how many degrees? If I ask the question, what is
Negative.
you know what inclination means?
It's a gradient.
Gradient, right? Does anybody know? Is there anybody who doesn't know what gradient means? Okay. What is the independent axis? X. So what is the inclination here? Isn't it 90 degree?
Yes, sir.
Yes, sir.
So those of us who studied mathematics from high school were told as religiously that x-axis is always the independent axis. So if you see a line vertical like this, that must be vertical to the x-axis, which is 90 degree. Now, if I say today, as economists do, that this is the independent axis, then is this line going to be 90 degree to the independent axis or 0 degree to the independent axis?
So 0.
Is there anybody in the class who doesn't understand? Mathematically, x is always the independent axis. So if we see a straight line like this on the x-axis, by default, our neurons automatically tell us, we are wired to see this as 90 degree. But if I paraphrase it or change it that, okay, no, y is the independent axis, then will you see it 90 degree or will you see it 0 degree?
0 degrees, sir.
আচ্ছা, কার অসুবিধা হচ্ছে বুঝতে? Is there anybody who doesn't understand? Is there anybody who doesn't understand?
Sir, I think if you flip it, it will be easier for people to see.
I can't flip it.
So maybe
I'll flip it later on, but is there anybody who doesn't understand what I'm trying to say? If x is in our independent axis, then this line will create 90 degree with the independent axis. Okay, we all agree. But if y is the independent axis, then the red line will create a 0 degree with the independent axis, right? Got it now?
yes, sir.
Okay. Now let's see. We said quantity demanded of x is a function of the price of x. But when we plot this relationship in a graph in economics, what happens? We are writing this as price. We are writing this as price. And if that is the case, isn't this the independent axis?
Yes, sir.
We are writing quantity over here. If that is the case, isn't this by definition the dependent axis?
Yes, sir.
So those of you who don't know mathematics, it's a blessing. You can change your orientation today. Those who are programmed, then you will have, now let us draw the line again. This is the demand function, say, huh? This is demand function 1. What is the slope?
Sir, 0.
Independent axis is over here now. Isn't it 90 degree now? Who said 0?
Sir, me.
Acha, you said 0 because you looked at the independent axis as x, right?
Yes, sir.
And then because it's not your fault. That's how we have been wired from school.
Otherwise, it would be infinite.
But if I now tell you, now we have agreed that this is the independent axis. If this is the independent axis, this same line, isn't it creating a 90 degree to the independent axis?
Yes, sir.
So that's why this the slope now is infinity or undefined. Is that clear now?
Yes, sir. So this is a problem I always had with economics. Like,
Just a second. Just a second. Let me stop it. Who said you had a problem?
sir,
What's your
please,
name?
sir, it's like Abul Khair Mohammad Fazlur Rahman.
Very good.
Sir, it's like my question is, like I have asked several times during my graduation. I did my minor in economics,
Okay.
and I asked every lecturer and all professors, like, why do they flip it?
Hmm.
Nobody could give me an answer that makes sense. All I could think is they just wanted to differentiate from physics because they adopted all this idea from physics.
Okay. So, but today you got your answer.
No, sir, I don't know why they flip it. Like, there is
Okay. Why they flip it is a different. I'll answer that question. Since you haven't got it, I'll give it to you. But now is the logic clear?
yes, sir. The logic is clear. I understand.
Okay, lovely. So now I'll give you an answer to your question. What was your question? Why does economics flip it like this, right?
Yes, sir.
Okay, there was a gentleman called Alfred Marshall. Okay, he was a Cambridge mathematician. He did a lot of contribution in economics. He was the culprit who made Y the independent axis. So this is known as the Marshals Convention.
Yes, sir. That I know.
You know that?
Yes, sir. I know. Like I think from he made a lot of contribution to economics in terms of maths. Before that, it was like considered art subject.
No, before that it was also mathematics, but there were other people even before Marshall who made lots of nice contributions in mathematics. But this convention is the convention of Marshall. He was the person who flipped it, and he was the first person who made the first proper economics textbook. So what happened? Since he did it like this, it stuck in the psyche of the economics discipline. Okay.
Okay, sir. So that's what I thought. Like, there is no logical.
There's no logic. There's no. It's just a convention.
Explanation for this.
For example, if tomorrow, if from our childhood, if we were told that our right hand is our left hand and our left hand is our right hand, it wouldn't have been any problem, right? It's just a convention we started off with.
Yes, sir.
Now is it clear?
Yes, sir.
So your doubt from your undergrad is now over, right?
No, sir, it's okay. So that's why I had to always, for economic courses, I had to do it twice. So I had to solve through graph and do it mathematically to make sure that my brain is not misfiring, because
Now your brain is misfiring, your eye might be misfiring.
yes, sir.
It is a visual matter, okay? Okay then. So basically, this is it. The graph shows us a functional relationship. That means quantity demanded is a function of price. The general form is y is equal to function of x. We know very well that the variable on the right is what? The independent variable. The variable on the left is the dependent variable. So that's why we are saying function
Sir.
of. Yes, carry on.
Sir, now when independent variables are remaining constant,
Huh?
then dependent variables
Okay,
will
so you
be
want to say that the
infinitive.
independent variable remains unchanged.
Yes, sir.
Okay,
Then
but the
dependent
dependent variable
variables.
is changing. Ito.
In this graph, dependent variables are infinitive, sir.
Okay, okay, I'll answer that question right now once we get to the concept of slope. Okay.
Okay, sir.
Well, once we get to the slope, I'll answer it. I'll try to show it graphically and visually as well. So where are we? Don't worry, if we don't understand, I'll repeat myself 2-3 times. So these another convention in economics is we are focused only on the first quadrant. Those of you who know, you know. Those of you who don't know, the logic is that on the first quadrant, the values of both x and y are positive. So we are looking at a variable, say price. Price may reduce. Price can fall down to maximum how much? 0. Price will never be negative. Okay, we're looking at a quantity. Quantity can fall, it can reduce, but it will never be negative. We can look at taxes. Taxes will never be negative. Whatever variables we look at in economics, they will always be positive variables. That's why in economics, we are focused only on the first quadrant. We are not interested in the second, third, or the fourth quadrant. Okay. Uh-oh. Okay. Who has problems understanding the concept of slope? Then I'll answer the person who just asked the question. Is there anybody who has problems understanding the concept of slope? Everybody understands slope, so I don't have to talk. Yes.
Sir, can you discuss its formula, sir, one time?
Okay, I'll do that one time. So you're the only person in the class who has problems with slope. There's everybody else
Sir,
understands
I'm
slope.
not clear. It's if
এই
you
তো
again
আস্তে আস্তে এখন
repeat it,
সবাই
please,
আস্তে আস্তে
sir.
করবে। That's good. I know a lot of you aren't clear.
So you
Okay,
should
so-
thank Iqbal because Iqbal does not have problem with slope. I think he volunteered.
Okay, he volunteers. He understands slope very well.
Yes, sir. I know he understands well.
Okay, so the lady who talked, what was your comment about slopes? One lady said that
Sir,
she
it's me, sir. I'm not really clear about the slope.
Okay, lovely.
So I asked about when independent variables are not changing, then dependent variable will be infinitive or
Ah,
not. That's the point.
I'm coming to that. That's when the denominator will be 0. I'll come to that. Okay.
Okay, sir.
And I remember your question. Don't worry. Okay. Letter. What is the black color? Where's the colors? Now let's see how we define a slope. We're doing a mathematical convention, huh? Does anybody have problems with this? Isn't this how we define a slope? Change in
Yes,
x?
sir.
Okay. Now slope is a ratio. Ratio is a mathematical way of comparing two things. The reference variable is always the variable at the bottom, which is the denominator. The variable that we want to change, measure, or want to see how it is changed, that is always on the top variable. For example, when we are asking for the speed of a car, we say that is 60 kilometers. That's not a correct answer. It will be 60 kilometers per hour. So the speed is always in reference to something. Now, if we say that it's 60 kilometers per second, then we're definitely talking about the speed of a rocket, right? So if I say that the speed is 60 kilometers, it doesn't make sense. Slope is just like that. It's a ratio. Whenever we talk about a ratio, we are comparing the numerator, the one on the top, with whatever is at the bottom, the denominator. So let's get back to our definition. If you have problems, stop me, I'll repeat myself. So when we are saying that change in y divided by change in x, in essence, we are looking at change in y in response to change in x. This is what we want to see. And This is the independent variable. This is the dependent variable. So what we are looking at, as the independent variable changes, which is the change first, how does the dependent variable respond? I'll tell myself again. Slope is a ratio, and the ratio we have said that we are comparing the numerator, the one on the top, with something as a reference variable on the bottom, the denominator. Then we said that we are looking at the change in y in response to change in x. When we say this, that means x must have changed first. Does anybody have any problem understanding this verbally? Change in y in response to change in x. That means x must have changed first. Does it, is that okay?
Yes, sir.
Okay, sir.
So x has changed, and then there is a change in y. Sorry, in response to change in x. Okay, can we move on to the next topic now? We don't have any problem with that, right?
No, sir.
Okay, now how do we define change in y? Don't we define it like this? Do we define like this?
Yes,
For
sir.
the ratios, yes, sir.
Yes, sir.
When we look at the change in only y, forget that x exists. Any change means the last value minus the first value.
Yes, sir.
So I'm just changing the names. So if we are looking at the change in y, we are looking at y, the last value of y minus the first value of y. For example, if your salary has increased by 10%, what do we do? Yesterday it was 100 taka, today it's 110. So what do we do? Well, how do we calculate the change? 110 minus 100. If your salary has decreased for whatever reason due to the pandemic, so what happens? The last value will definitely be small. 90 minus the first value that we started off with would have been probably been 100. So 90 minus 100 would have been a negative value, right? Yes?
Yes, sir.
Yes, sir.
Good. We do the same thing with x. Change in x is defined as x, the last value of x minus the first value of x. I like to use the word post and pre. Post minus pre. So isn't this del y? Isn't this del x?
Yes, sir.
Okay. So now we are formally doing the slope. Slope is equal to y post minus y pre divided by x post. If you're not happy with post pre, you can use last and first, whatever you like. Okay. This is just a reference thing. Now, a ratio can have only 3 values. How? If the top is greater than the bottom, then ratio must be greater than 1. Forget the sign. Can it be anything other than greater than 1?
No,
If the
sir.
top part is greater,
No.
ratio is just a comparison. So if the top is greater than the bottom, ratio must be greater than 1. If the top is less than the bottom, ratio must be less than 1. If the top is equal to the bottom, ratio cannot be anything but 1. Taina?
Yes, sir.
So when we are looking at a ratio, the reference number is always 1. Either it's more than 1, the ratio, so the change in y must be greater than the change in x, or it's less than 1, so the change in y must be less than the change in x. Or the last one, if it is the reference one, then the change in y is equal to the change in x. এর বাইরে আর কিছু হবে? Can it be anything other than this? Can it be anything other than this? When we compare the numerator with the denominator,
Sir, what about when numerator or denominator is 0?
I'm using the number 1 only. I'll come to 0 and infinity later, but can it be anything other than this one reference?
No, sir, it's the most convenient
It,
reference.
it has to be 1. Either it's greater than 1, then the top is greater than the bottom. It's less than 1, top is less than the bottom. Otherwise, it's equal to 1. So the top and the bottom are the same, right? Okay.
Yes.
Now, the person who said 0. So if y, change in y greater than change in x, then slope must be greater than 1. If change in y less than change in x, slope must be less than 1. Oh, you didn't know. And if change in y is equal to change in x, then slope must be equal to 1, right? এর বাইরে আর কিছু হবে? Is it possible? Huh?
No, sir.
Now, when something is greater than 1, what is the maximum value? তাই না? এর চেয়ে বেশি হবে?
No, sir.
When something is less than 1, what is the maximum value?
Negative infinity.
Negative infinity হবে না.
0.
We start counting from 0. Okay.
Okay.
So that's the other two cases, that when we say greater than 1 or less than 1, greater than 1 by how much more? A very large quantity, whatever that large quantity is, whether that's infinity or that's 35 million, doesn't matter, it's a large quantity. Less than 1 means how much? It can be maximum 0. So the range of a absolute value of a ratio will always be in between 0 and infinity. Is that clear now?
Yes, sir. So those are like the limits.
These are the two limits, but the reference number for comparison is always 1, because we are comparing the numerator with the denominator, and then one can only be larger, equal to, or less than the other. এর বাইরে আর কিছু হবে না. There can be no other logical possibility other than these three.
Yes.
Then the question is, if it is greater than 1, by how much? If it is less than 1, by how much? Those are the two, so that we get the two extreme points. Okay, clear?
Yes, sir.
Okay. Now, now we address that question. Independent doesn't change. Who said that independent doesn't change? Somebody asked this question, and now I'm going to answer that person's question. Huh?
Roslyn, sir.
Roslyn. Your name is Roslyn.
Yes, sir. Roslyn Farhana.
Okay, lovely. Then this is the dependent. You said that the independent doesn't change. So if the independent doesn't change, what does that mean? That means before and after, the value of x is the same, right? Yes?
Sir.
Huh? If x doesn't change, that means before a change, whatever the value of x we had, after the change, the value of x is the same. So x has not changed, right?
Yes, sir.
So what happens? Del x becomes 0. So if the new denominator is 0, what is the value of the slope now? Isn't it undefined?
Yes, sir. Undefined.
Undefined or infinity, whatever. Some books say that infinity is undefined. Some books use the word infinity, but The thing is, if the new denominator is equal to 0, can we, isn't it undefined or infinity? This ratio?
Yes, sir.
Yes, sir.
Whatever the value of y, if the change in x is equal to 0, that means the same x before and after the change, then this ratio must be equal to infinity. Right?
Yes, sir, right.
Okay, so now your question was what? If the change in independent variable is unchanged, that means it's 0, then what will happen to the graph? That was your question, right?
Yes, sir.
Okay, lovely. Now we address that question. I'm saying like this because you see in school, they don't teach these things. When I was a student, nobody taught me. Okay. This is our x-axis. This is our y-axis. Okay. Let's take 2 points now. x0, x1. They're the same value. Then we do another line over here. Okay. Oh, this is not. This is just a second. Where's this eraser? Okay, let's try again. কি হয়েছে?
Almost.
Almost. Doesn't matter if it's 89. Nobody can tell the difference, তাই না?
Correct, sir.
Okay. So this is y1. This is y0. What is the change in y?
Y1 minus Y0.
y1, y0. Is it a positive change or a negative change?
Positive.
Why? Because we're moving upwards. So if we are moving like this, then del y is positive. What is del x?
So,
0.
Roslyn, what is del x?
I said it fixed.
No, fixed money key. What is the change? x0 minus x1.
X0.
Isn't it 0?
Yes, sir.
So what happens to the slope now?
Positive changes. Y.
What is the slope now? Isn't it undefined?
Infinite. Yes, sir.
Now you got it?
Yes, sir. That's why I am asking. It is similar to the first graph.
Yeah, it's similar to the first one. That's why it's happening.
Yes, sir.
Okay. Now, if I say that the independent variable is the y-axis, then what will the slope be? এটা slope হয়ে যাবে না?
0.
No, 0. Forget the 0. Look at the formula first.
Oh, yes, sir.
Do we all agree that independent axis is now the y-axis? Dependent axis is now the x-axis. So this same graph, x, there is no change in x. So this becomes 0. Whatever the change in y, isn't the slope now going to be 0?
Right. Yes, sir.
Does it বাকিরা কি একমত? Do the others agree as well?
Yes, sir. Yes.
Anything divided with 0 is 0 ultimately.
If you divide something by 0, it's going to be an undefined quantity. It's going to be something very big. So the main objective of saying everything like this was that visually, whatever we are familiar with from a mathematics convention is going to get going to get flipped up when we look at an economics convention, because the y-axis 99 out of 100 times will be the axis of the independent variable. X-axis 99 out of 100 times will be the axis of the dependent variable. So if we now look at this, where is it? This is the mathematics convention. Can you see the graphs? The 0, the blue. Can you see the slide?
Yes,
Yes.
sir.
Okay.
Yes, sir.
Now, over here it's written 0 because it's parallel to the x-axis. X-axis is the independent variable. But if we make this the economics graph, what will the slope be?
Sir,
Slope of this one. What will the slope of this one be?
Sir, undefined.
Undefined, it will be infinity. Now look at the undefined one. If we are thinking from a mathematics point of view, then we are wired that x-axis is the independent variable, and this black straight line creates a 90-degree gradient with the x-axis. But if this was an economics convention, then this black is creating a parallel to the y-axis. Then the slope becomes 0. Got it? And that's why I've written here how dependent variable changes in relation to the independent variable. So if both of them are increasing, it's positive. Both of them are decreasing, it's negative. And these are the two extreme cases. But that depends on how we define the axis. এটা তো আমরা লাস্ট ক্লাসে বলছি, শুনে এটা তো আলাপ করার দরকার নাই এই দুইটা, তাই না? Opportunity cost and sunk cost.
Yes, sir.
We don't need to do those, they're khamaka. Acha, this is something we need to go for. Marginal decisions. Okay, let me, when we make a consumption decision, will we consume 10 glasses in one shot, or we will consume one after another?
One after.
Normally we consume one after another, normally, right?
Yes, sir.
Right.
Okay, this brings us to the notion of differentiating between two things. What do we understand by second, and what do we understand by two? Can somebody answer this question? What is the difference between second and two? Both have two in front of them. What is the difference between second and two?
Second is a sequence.
Second is a sequence.
It comes after first,
Okay.
and two is like a number.
Both of them
It
are
is not a
numbers.
sequence. It is not a sequence. Sir.
Sir, I think, sir, it's more like 2 is a quantity, whereas second is a discrete.
Second isn't a quantity.
position. So it is
Second
a
is also a
discrete,
quantity.
it's a discrete position, like it refers to one object,
Mhm.
which is second,
Mhm.
whereas 2 refers to like there are 2 of something.
Two of something, you are coming very close. When we say the number 2, we are calculating from 0 to the end of number 2, the second unit. When we say second, we are looking at only one unit, the end of number 1 to the end of number 2. Is that clear? I'll say it again. When we say 2, we are calculating from 0 to the end of the second unit. Okay? When we say second, we are calculating only one unit, the second unit, not 2 units, right? So let me show it to you in graph. I think I'm not being able to. Is it? Is it clear now what I'm trying to say? When we say 1, sorry, not 1, 1 and the same. When we say 2, we are calculating from 0 to 2 now. When we say 2, I have 2 taka in
Yes.
my pocket. But if I say this is my second semester, how many semesters am I calculating?
1 semester.
1. Similarly, if we take it a little bit more, whatever, huh? So, so suppose this is 3. Uh-oh. I'm still not good at it. Anyhow, so this is third. When we say 3, we are calculating like this now. Huh?
Yes, sir.
Okay, now when we make decisions incrementally, this is the word that you're going to look at your text. Increment means unit by unit. 1, 2, 3, 4. We're counting. But when we make an incremental decision, we all calculate. How do we calculate? First, second, third, fourth. So let's assume that your MBA program is going to be 4 semesters. Whatever performance you make in the second semester happens first, which is your GPA. That is the marginal change. After you finish your second semester, only then and then can you calculate your CGPA. Can you calculate your CGPA without knowing your GPA?
No, sir.
No, sir.
No, sir.
Never. Marginal change is always the change that happens first. Marginal change is the change first, second, third, fourth, one particular unit. After we finish that second semester or the third semester, only then can we calculate the CGPA of 2 semesters or 3 semesters. When we say CGPA, do we calculate for second or first or third? We calculate as 2 semesters, 3 semesters, right? Do we calculate CGPA for a particular semester or for a stream of semesters?
So for a stream of semesters.
Oh my God, reverb হয়ে গেছে, যাক। And but when we calculate the marginal change, we are calculating a particular semester. So marginal is always first, second, third, fourth. Average is 1, 2, 3, 4. Now, if my marginal change is improving, isn't my average also improving? If my GPA is increasing, then definitely my CGPA must be increasing, right?
Yes, sir.
If my GPA is falling, then my CGPA must be falling. If my GPA remains unchanged, which is the condition for equilibrium, then my CGPA must also remain unchanged. So when we make calculations in economics, what we do, marginal change is basically a change of second or third. Seconds, okay, over here we've done second. That means end of 1 to beginning of 2. But once we finish the second semester, we can then calculate a CGPA from 0 to the end of 2, which is from 0 to N2. So if GPA is increasing, then definitely CGPA must be increasing. We all agree to this, right? Do we all agree to this? If our GPA is increasing, which is the change that happens first, the marginal change, then we know that our CGPA is also increasing, right?
Yes, sir.
Okay. This in economics terms, I'm using GPA because this is how I taught it to my daughter last year when she started economics. And I told her that I'll show it to you like this, you'll never forget. You guys also will never forget. When marginal change happens first, and if marginal is increasing, GPA is increasing. That means the change after the marginal change is the average change, that must also be increasing. So if your GPA has increased in the second semester, CGPA must be increasing at the end of 2 semesters. Got the logic now?
Yes, sir.
Yes.
So GPA is just your marginal change, CGPA is your average change. Once we get into more details regarding the graphs, etc., which we will, it will become more clear. Okay. ঠিক আছে? Okay.
Yes, sir.
Okay, so what we'll do, my God, we started at 7:10. It's 8:44. 90 minutes have gone. We'll have, it's now 45. Shall we start at 55 again? 8:55?
Yes, sir.
Okay, we'll have a little break. I'll disconnect. I'll come back after 10 minutes. Okay.
Thank you, sir.
Okay, we'll come back after 10 minutes, no problem. And then we'll start at 9 again. Hopefully we'll finish in half an hour.